Hello, Mark. So, to answer your question, let me pull. Okay. So the question is, determine if the set of vector is a basis or not. If not, determine the dimension of the subspace spanned by the vectors 1, 1, 1, minus 1, whatever that is. So now a set of vectors are basis if they can explain the whole space. Like as in you have 5 vectors and all of them are 5-dimensional vectors, but are they linearly independent? Can they explain, can you use them at like coordinate to explain a coordinate in 5 dimension? To go in detail, let me plot something. Since 5 dimension is going to be very difficult to understand, we're going to try to picture it in 3 dimension. So let's do this. I'm doing it in Python to give you a visual understanding. Let's see, first import the necessary library. Now I'm going to plot. I'm making this picture a little larger. I'm going to plot a couple of vectors here. So the vectors I plotted here is 1, 0, 1, 1, 1, 1, and 1, 0, 0. As you can see, they are not exactly perpendicular, but they are independent. So you can explain any point in the space with the help of these in the 3-dimensional space. But now, if you come to the next picture, these are also 3 vectors. And the 3 vectors here are 1, 0, 1, 1, 1, 1, and 1, 0.5, 1. As you can see, these 3 vectors looks like they're on the same plane, which they are. So now you can't explain a 3-dimension with these 3 vectors because they are not linearly independent. You can only explain a 2-dimensional space with these. So why is this? Is because if you look at the vectors, you can get the third vector by adding the first 2 and dividing them with 2. So if you add the first 2, this becomes 1 plus 1, 2, and then 1 and 2. And then you divide them by 2, it becomes 1, 0.5, and 1. So the third vector actually a linear combination of the first 2. So that's why you can't, these 3 vectors cannot span this 3 dimension, where these 3 vectors can. So these can form a basis. This cannot. So now you have 5 dimension. 5 dimension and 5 vectors. Now, can they form a basis? Maybe, maybe not. One way to check if they're linearly independent is a method called Gaussian elimination. It's been some time. But so what Gaussian elimination does is just it step-by-step reduces tries to find out how many independent vector there are in a matrix. So we do it to find the rank of a matrix, which is kind of like the subspace can be explained by that matrix. So what I'm going to do is make these vectors as a matrix. So we are writing these 5 vectors that were given in the question as a matrix. So you can see I wrote this matrix. So the matrix has the first vector as its first row, second vector as its second row, and the third vector as its third row, and then so on. So now what we can do is we can subtract the first row 1 1 1 from the last row. So that's what I'm going to do. So since it's Python uses zero-based index, so that's why I'm using 0. So that's going to be like 1 less than the row number actually in real life. But anyway, so I'm subtracting this first row from the fourth row. So you're going to get this 1 will become 0, this 2 will become 1, this minus 1 will become 0 as well, and then so. Similarly, I will also subtract 2 times the first row, add 2 times the first row with the third row, and subtract 2 times the first row from this third row, and just add the first row with the second row. So after doing that, what we get is this one. To make it much clearer, more clear, this is what we get. As you can see, we already have 0 for all of these rows. Okay, so which is a progress. Now we're going to try to make more zeros so that we can actually see how many rows we can make totally 0. So as you can see, so here you have 1, here you have 3, here you have minus 1, here you have 1. So I'm going to take the second row and add or subtract from all of the lower row so that I can make them 0, at least in one element of this row. So I'm going to do these operations and I get these. So now if we look at the first one is the same. I did not try anything. Second one is you have 2 zeros. On the third one, you have 1, 2, 3, 4 zeros and 1 non-zero. This one also same, this one also same, but they're also the same element in the row. So what I can do, I can subtract the second, this third row from the fourth and fifth row, which is what I'm doing here, and I end up with this. Now, I can't do any more operations that will reduce the number of rows because you can subtract these plus, minus, or whatever, but it's not going to reduce anything. So now we have 3 rows that is left. So that means the vectors that you have can only span 3 dimensions. So they can explain a system of a 3 dimension, even though they're 5-dimensional vectors. So let me see. So that's this. What's the dimension of subspace? So the dimension of subspace is 3. So 3 dimension can be explained by this vector. I hope that answers your question. Best of luck.